Good day to the judges. We are Team Stanley and the gang, and our team members are Stanley, Tsai, and Adrienne. In this video, we will be presenting about our invention for the MaGIC competition. Our objectives are to solve the environmental issue, to create an environmental friendly product, and to achieve SDG 7 and SDG 13. Next, Stanley and the gang have come to a conclusion that improvised web shark is our final product. So I will introduce about a bit of background of web shark. And web shark is an aquarium that removes plastic and other floating debris from the water surface. It is produced by RAN Marine Technology through a startup accelerator program for port innovators in Rotterdam. The web shark was designed especially for use in ports and harbors, and it can collect up to 350 kilograms of trash at a time. The electrically propelled drone produced zero carbon emissions, and the development of an autonomous docking system for the web shark was supported by the FKI-RIC. The algorithm supplied by the FKI enabled the drone to find its way back from the harbor, heading to the docking station where it can deposit trash and recharge its batteries. Next, I will explain about the design of the improvised web shark. So the original web shark model uses electricity to propel and could only collect the floating plastic waste. So the improvised model uses solar energy to propel and it collect microplastics. Solar panel is added on top of the model as shown in the figure to collect solar energy to be converted into electricity, and there is a big magnet attached to the base of the improvised model. This is because we have referred to a study by Keong about ferrofluid, and through the research, he found out that microplastics can attach to ferrofluid and they can be removed by using a magnet. A magnet would remove the solution and leave behind only water, and hence no water pollution will occur. In the process of using this improvised web shark model, the ferrofluid has to be released manually into a river before deploying the model. The ferrofluid was left to attract the microplastic, and when the drum is deployed, it collects the plastic waste along the surface and the released ferrofluid. It can be controlled by radar, and the rate of the movement of the drone is set before deployment. The ferrofluid can be reused for 5 cycles before replacing with a new ferrofluid. And the model of the improvised web shark is shown in the figure. And the reason why we choose the improvised web shark as our final product is because improvised web shark is environmentally friendly. It is said so because the improvised web shark uses solar panel to generate electricity to propel, and the renewable energy is used. And it does not emit any pollutants, as it improves the water quality by collecting the floating trash floating on the water surface. It produces zero carbon emissions that I mentioned before. Next, improvised web shark is also economically viable. The web shark has to be cleaned after every 10 hours of operating. The cost should not be higher than 700 ringgit Malaysia per month for the labor fee. And the cost of a web shark is about 100,000 for one. The annual cost of building a web shark is said to be comparable to the cost of watching TV for 5 hours every day for a year, which is around 48.39 ringgit Malaysian. But since the improvised web shark operates on solar energy, it costs almost zero for recharge. Since ferrofluid is made up of oil and iron fillings, it should not cost more than 50 ringgit, and it can be used for 5 cycles, so the total cost per month is only 1,500 ringgit approximately. Apart from that, improvised web shark is also technically feasible and scientifically sound. The waste jar does not cause any harm towards organisms around it, as it has LiDAR and a set path mission that is set to avoid both static and moving objects in the water. And the ferrofluid is completely removed from the water by using just a magnet. Also, it can collect up to 350 kilograms of trash at a time. Last but not least, improvised waste jar is also an innovative product. This is because the waste jar collects trash that floats on water surface and the microplastic in the water by using ferrofluid. And it was waypoint planning that enabled it to move around without being monitored. It can last 10 hours of waste collection before recharging itself at the port provided. Next, I will show the prototype of improvised waste jar in the video. That will be all from us. Thank you.